The last thing I've got for us to look at is solving logarithmic equations. And it's similar in the sense that we need to simplify the equation as much as possible. So whatever we can simplify so that we can get down to an isolated log statement. With the exponentials, it was similar. We needed an isolated exponential. And when we had the exponential, we did the log on both sides. Well, these are log equations. So algebraically and theoretically, we could put an exponential on both sides. And it is a valid strategy for solving these algebraically, is doing an exponential on both sides. But I found the notation for a lot of students doing it that way is really cumbersome, and they kind of get bogged down in the notation. So I'm going to show you an equivalent way that is particularly good when these log equations are on the medium to easy side. And that's where we rewrite the log as an exponential. And that will give us an exponential equation to solve. Now that requires us to review, just refresh a little bit about rewriting log equations as exponentials. Now, you've done 100 of these in previous homework assignments, but I just wanted to refresh the idea and then show you how that skill you learned on changing a log to exponential can be used to solve an equation. So if you're using my note packet does not have these two problems in them. So these are like two free problems. They're real quickies. And then I have two hard log equations that we can solve together. But if we were to rewrite this, remember that logs always equal an exponent. So Q is the exponent on our expression, and A is the base. So this is logically equivalent to A to the Q power equals W minus 1. So that is a rewrite of the log expression. So we're just changing the exponent from the log into its exponent position on the base A. So with that little skill, you've done that a bunch of times, we can use that to solve equations. Now notice in this second problem here, solve for W. There's only one unknown. We just need to figure out what W is. And so if we rewrite this equation, it may not be obvious how to solve it now, but if we rewrite it, we'll get 4 to the third power equals W minus 1. Well, now, without the log in the equation, it's a lot easier to solve. 4 to the third power is 64. W minus 1, add 1 to both sides. We're done. W equals 65. And then, of course, we need to check, because there's a domain problem. If that domain is negative, it'll be no solution. But that's the basic idea. We just solved the log equation. That was a simple one. And the basic strategy can repeat on harder equations. Okay, now I have two harder equations. And to keep things consistent and straightforward, I'm just going to use the same method over and over again. I'm going to solve by rewriting the log into exponentials. So we see a natural log. Now the log is already isolated. I have the log all by itself. It's a natural log, and I can immediately rewrite this equation. So 6 is the power. It's a natural log, so if I rewrite it as exponential, it has to be base E, has to be 6 power, and it's going to be 25 times 1.25 to the x power. I'll just put parentheses here. And I can start working towards getting x by itself. So I'm going to divide that 25. E to the 6th over 25 is 1.25 to the x. Oh wait, x is an exponent in this expression. So this is kind of a combined problem here. And I can solve that now like we solved our exponentials before. I'm going to use a natural log on both sides. And that allows me to simplify the right side. And now I have a multiplication, and I'm one step away. All I have to do is divide the ln of 1.25 on both sides. So that all cancels, and now I have x by itself. $25 here over ln of 1.25. Okay, so there is an exact solution, and I can plug all that into a calculator and get a decimal round off. I might be able to simplify this a little bit, and now we have to be careful about the log laws. Can I turn this division into subtraction? Question. The answer is no, because we have to be really careful and not invent new logarithm properties. This is a log divided by a log. Rule number 7 is one log with division inside. This division is not a division inside a log function. So I cannot, the answer to that is no, I cannot do this. I cannot separate that into subtraction. All right, so be careful, because this division is not a division of a numerator and denominator inside a log function. However, what about this? How about that? Can I simplify that division into subtraction? And the answer to that is yes. This one I can simplify because that division is inside a log function. So the top part of this I could make simpler if I wanted to by using rule 7, and I'm going to put a little mark here to clean that up, another step here. So I cannot do anything about the bottom. That's stuck. But the top I can separate into log e to the 6th minus log of 25. And then lastly, natural log of e to the 6th. This is going to simplify more into 6. And that is as simple as I could make this problem. Both of these are exact. Both of these are correct answers, and you kind of have to choose which form makes more sense to you as far as being simplest. Now, some of you that are really competent with logarithm properties, you could solve this another way. And I didn't want to go that way because I wanted to teach you just one way, but it would have been possible to start with rule number 6 at the very beginning. And those of you who feel confident with logs, try solving it by doing that first and see what happens. And you'll see that you get this same solution here if you've done it correctly. But let's do one more. I have another one that's a little harder still, where the equation has 2 log functions in it. And so let's see, how can we solve this? Well, we would need x by itself, but I got x twice, and x is inside of 2 logs. Let's see if we can isolate these logs into 1. And that means doing some simplifying here. And I'm noticing a plus. A log plus a log, hey, that's like this rule number 6. So I could combine these two logs, a log plus a log, into one log function with a multiplication inside. Now notice I'm doing the parentheses, x times x minus 1. So this will equal log of x squared minus 21x equals 2. So by using the log properties, I combined the two logs into one expression, one log, and now, so that I did and that I did. Now I can rewrite this. It's really easy to rewrite. It is log, so that means when I rewrite, in fact, I'm going to change colors for the rewrite here. It is base 10, log base 10, exponent is 2, equals x squared minus 21x. This is a quadratic equation. We can solve quadratic equations with factoring or the quadratic formula if they equal 0. So I'm going to minus 100 on both sides, and I got my equation equal to 0. So 0 equals x squared minus 21x minus 100. And sometimes they factor, and sometimes we have to use the quadratic formula. But in this case, I'll let you break down those factors and see how that works yourself. But this is going to be two solutions. So far we got x minus 25 equals 0. So we would have x equals 25 or x equals negative 4. When we are using logs, it's important to remember logs have domains. Recall, a log only works on a positive value. The domain is 0 to infinity, so I need the inside to be greater than 0. So it's important to check your solutions. We have two good solutions, and these two solutions work for this quadratic equation. But do they work for the quadratic, for the log equation? We've got to check. And check that it's going to be 2. It's going to work just fine. However, when we check the other one, let's put in negative 4. And you're going to see it failed. Negative 4 minus 21. Here I have, in both cases, I have a log of a negative. And you can even do it in your calculator and check, and you're going to get an error. Turns out this one is not a solution. When we put it into the log equation, it doesn't work. It worked in the quadratic equation, but not in the original equation. We call those extraneous solutions. So the important principle to take home from this is you should check your solutions. Okay, so we've looked at a couple of the harder log equations to solve. I hope that was helpful. Study hard, and I'll see you in class.